When applying tap rules to parallel conductor runs, the ampacity requirements pertain to the individual conductors within each parallel run, not the total combined ampacity of all parallel conductors. This means that each individual conductor must meet the ampacity requirements as dictated by the tap rules, considering factors such as conductor size, insulation type, ambient temperature, and any applicable dilating factors. Let's break this down further. The tap rule is a provision within the National Electrical Code, or NEC, that allows conductors to be tapped from a larger feeder or main conductor under specific conditions, such as length limitations, overcurrent protection requirements, and ampacity considerations. These rules are designed to ensure electrical safety and prevent overheating or damage to conductors due to excessive current flow. When conductors are run in parallel, which is a common practice for increasing ampacity, each conductor carries a portion of the total load current. The NEC permits conductors to be run in parallel under certain conditions outlined in section 310.10. For example, the conductors must be the same length, conductor material, insulation type, and be terminated in the same manner. When applying tap rules to these parallel runs, it is essential to consider the ampacity of each individual conductor separately. The tap rule ampacity requirements do not refer to the total combined ampacity of all the parallel conductors. Instead, each conductor within the parallel run must independently meet the requirements of the tap rule. For instance, if a tap rule requires a minimum ampacity of 100 amps, each individual conductor in the parallel run must have an ampacity of at least 100 amps, irrespective of the total ampacity provided by the parallel conductors collectively. The reason for this is to ensure that each conductor is adequately sized to carry its share of the load current without exceeding its ampacity rating. Overcurrent protection devices, such as circuit breakers or fuses, are typically installed at the point where the tap conductors connect to the larger feeder or main conductor. These overcurrent protection devices are sized to protect the tap conductors from overcurrent conditions such as short circuits or overloads. The overcurrent protection device must be sized no greater than the ampacity of the tap conductors. In the case of parallel conductors, the overcurrent protection device is sized based on the combined ampacity of the parallel conductors, ensuring that the entire circuit is protected from excessive current flow. However, when applying tap rules, it is crucial to verify that each individual conductor in the parallel run meets the minimum ampacity requirement specified by the tap rule. This is particularly important when dealing with long tap conductors or situations where the tap conductors supply a significant portion of the load current. To further illustrate this concept, consider a scenario where three conductors are run in parallel to supply a load. According to section 310.10, all three conductors must be the same length, conductor material, insulation type, and be terminated in the same manner. If the tap rule requires a minimum ampacity of 80 amps for the tap conductors, each of the three conductors in the parallel run must have an ampacity of at least 80 amps. The total combined ampacity of the three conductors would be 240 amps, but the tap rule focuses on the individual conductor ampacity to ensure that each conductor is adequately sized to carry its share of the load current. This approach ensures that even if one of the parallel conductors were to become disconnected or fail, the remaining conductors would still be capable of carrying the load current without exceeding their ampacity ratings. This provides an additional layer of safety and reliability to the electrical system. It is also important to note that the tap rules often include specific requirements for the length of the tap conductors. These length limitations are designed to minimize the risk of voltage drop and ensure that the tap conductors are adequately protected from overcurrent conditions. The length of the tap conductors is typically limited to a certain percentage of the length of the feeder or main conductor from which they are tapped. When applying tap rules to parallel conductors, the length limitations apply to the entire parallel run, not just individual conductors. This means that the total length of the parallel conductors must comply with the length limitations specified in the tap rule. Furthermore, the tap rule may also include requirements for the type of overcurrent protection device used to protect the tap conductors. These requirements may specify the type of circuit breaker or fuse that must be used, as well as the maximum allowable rating of the overcurrent protection device. When applying tap rules to parallel conductors, it is important to ensure that the overcurrent protection device is properly sized and installed in accordance with the NEC and the manufacturer's instructions. In addition to ampacity and length limitations, the tap rule may also include requirements for the location of the tap conductors. These requirements may specify whether tap conductors can be connected to the feeder or main conductor, as well as any restrictions on the routing of the tap conductors. When applying tap rules to parallel conductors, it is important to comply with all applicable location requirements to ensure that the tap conductors are installed in a safe and accessible manner. It is crucial to consult the latest edition of the National Electrical Code, or NEC, and any applicable local codes or regulations to ensure compliance with the tap rule requirements. The NEC provides detailed guidance on the installation and sizing of electrical conductors, including tap conductors and parallel conductors. Failure to comply with the NEC and local codes can result in electrical hazards, property damage, and legal liabilities. Moreover, it is recommended to consult with a qualified electrical engineer or licensed electrician to ensure that the tap conductors are properly sized and installed in accordance with all applicable codes and regulations. These professionals have the knowledge and experience to assess the specific requirements of the electrical system and recommend the most appropriate solutions. In summary, when applying tap rules to parallel conductor runs, the ampacity requirements pertain to the individual conductors within each parallel run, not the total combined ampacity of all parallel conductors. Each conductor must meet the minimum ampacity requirements specified by the tap rule to ensure electrical safety and prevent overheating or damage to conductors. It is essential to consult the NEC and any applicable local codes or regulations to ensure compliance with the tap rule requirements. Remember that conductors in parallel must meet all requirements in 310.10 of the NEC. This includes being the same length, conductor material, insulation type, termination method, and cross-sectional area. Failing to meet any of these requirements invalidates the parallel installation.